Grade 10 learners, welcome to this session. My name is Mohapi. I'm working here at Mutao Education District, Mangaung Metropolitan Education District as the sub-advisor for mathematics. So today I want us to discuss identities involving Pythagoras Theorem. Identities involving Pythagoras Theorem. This is a section in trigonometry. It's a part of trigonometry, and it's very much important. For you to be able to answer this section, you must be familiar with the cast diagram. Let me remind you about the cast diagram. You have a Cartesian plane. These are the x-axis, the y-axis. In the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. And cast diagram, C-A-S-T, the cast diagram. What is its role? The role of the cast diagram is to indicate positive ratios. Everything that you are seeing here, it shows positive. In the first quadrant, all trig ratios are positive. Hence, we have A. In the second quadrant, only sign is positive, meaning tangent and cos are negative in the second quadrant. If you go to the third quadrant, you have T for tangent. Tangent is positive in the third quadrant, meaning sine and cosine are negative in the third quadrant. Same applies to fourth quadrant, where we come across C, and C represent cosine. Cos is positive in the first quadrant, meaning tangent and sine will then be negative. So you need to know the cast diagram by heart. What type of problems are we going to encounter? Sometimes the examiner can make a question a bit easier by providing you with a diagram. Check this example. Got a Cartesian plane, x, the y-axis, this is O. Then they said you've got a terminal side P here, a point P. And then they say that point, the x value say is -3 and the y value is 4. Here is P. Line OP. They give you x as -3, y as 4. It's OP. Then the question say, determine the value of, calculate the value of number 1, 25 cosec squared theta. So the angle here, they will give you theta in the standard position like that. This angle here is theta. Remember, every time they give you an activity like this, the first task that you need to do is to complete a right angle triangle. They can give you an arm. It's easier this way because already you don't have to structure by a quadrant. Already this terminal arm already is in the second quadrant. So the issue of identifying a quadrant is not an issue here because we've got the quadrant as the second. So your task is to complete a right-angled triangle. A right-angled triangle, 90 degrees. So this sign here, that is a sign for 90 degrees. And remember, the coordinates in order pair is given as x and y. So the value of x here is -3 and the value of y is +4. Remember, x values horizontal, y values vertical. The slanting one that will represent the hypotenuse. So if you look at this, we have this side as -3, this side as 4. What will be the length of OP? What will be the length of OP? Then we need to work out the length of P by using Pythagoras Theorem. We need to work out the length of OP. And according to Pythagoras Theorem, OP squared, Pythagoras theorem, the square on the hypotenuse is equal to the sum of squares on the other two sides. Pythagoras theorem is only applicable in a right angle triangle. And even when you state the Pythagoras theorem, wherever you read it, it clearly stated that in a right angled triangle, the square on the hypotenuse is equal to the sum of squares on the other two sides. hypotenuse is this side that is opposite to 90 degrees. We have 90 here. A side opposite to 90 degrees is the hypotenuse. So OP squared is basically the hypotenuse. This is equal to the sum of squares. You take 4, you square it. You take -3, you square it. The square on the hypotenuse is equals the sum of squares on the other two sides. Now, let's simplify. You square this one, it's 16. -3, you square it, is negative multiplied by -3, which is basically 9. Then you have OP squared. 16 plus 9 will give you 25. Therefore, the question we wanted to determine the length of OP. To determine the length of OP, we need to eliminate the square. And how do we eliminate the square? By introducing the square root. If you determine the square root of OP squared, you'll be left with OP. What you do on the left, you must also do on the right. The square root of 25 will then be 5. It means the hypotenuse, say OP, the length will be 5. Now we can answer the question. Remember, the question wanted us to calculate 25 cosec squared theta. It was 25 cosec squared theta. So if you simplify this one, you have 25. What is cosec? Cosec is defined as hypotenuse over opposite. Definitions of trig ratios, you need to remember we have 6 trig ratios: sine, cos, tangent, secant, cosecant, and cotangent. As a grade 10 learner, you need to know the definitions by heart, so that whenever you come across cosec, you know very well that cosec is hypotenuse over opposite. So with respect to this diagram, our hypotenuse is 5, our adjacent will be 4. You've got 5 over 4. You've got 5 over 4, and then because it is squared, you square it. Simplifies 25. This is 25 over 1. You multiply by 25 over 16. And 25 by 25, you take your calculator. I think 25 should be 225. 25 by 25 will then give you 625. 625 over 16. That is your answer to that question. Simply by it. What is of utmost importance in this case? Remember at the beginning, already we had a terminal arm in the second quadrant. So it's a bit easy because already the quadrant has been identified for us. So your task as a grade 10 learner was just only to complete a right angle triangle. Here it is, we completed it. X is -3, Y is 4. Then there was this side that we did not know. So the remaining side, we used Pythagoras Theorem to calculate the remaining side. Then the remaining side, which was OP, is 5 units. So if OP is 5, you write 5 here. Now, our right angle triangle, we know the 3 sides. The cosec is defined as hypotenuse over opposite, 5 over 4. Then if you square it, 25 over 16, multiply the 2, you've got 625 over 16. So this thing is basically 625 over 60. Let's check. Let's say for intersect, the second one, you are requested to calculate sine squared theta plus cos squared theta. Uses the very same diagram. Sine squared theta plus cos squared theta. Check. Sine. Definition, sine is opposite over hypotenuse. Let's check. Sine here is theta, opposite over hypotenuse. It's 4 over 5. You've got 4 over 5 here. You square it. Plus the cos. Remember, cosine by definition is adjacent over hypotenuse. The adjacent side is -3. The hypotenuse is 5. So adjacent cos is -3 over 5. It's right. -3 over 5. Because this cos is squared, you square this ratio. You square that ratio. Let's see what answers do we end up with. Allow me to use this section on top here. 4 over 5. If you square it, you square 4. It's going to give you 60. This will be 16 over, you square 5, you've got 25. Plus, check this one. It's negative, but when you square it, because it's squared, the answer will be positive. If you square this, it will be 9 over 25. 9 over 25. And let's add the 2. 16 plus 9 will give you 25. It will be 25 over 25. Simplified, the answer is 1. Meaning sine squared theta plus cos squared theta, ultimately the sum will be 1. Remember, how did you arrive at that? We used a right-angled triangle in the second quadrant, because already from the word go, we're given point P in the second quadrant, meaning the terminal arm is in the second quadrant. The coordinates -3 and 4 were given. Our task was just to calculate the hypotenuse, and then we are able to answer all those questions. I hope you are following and you are enjoying this session as much as I am doing. Let me take you through another example. The second example. Example 2 reads 5 cos A plus 3 squares to 0. 5 cos A. The cosine of A plus 3 is equals to 0. And 180 degrees is less than A, and A less than 360 degrees. The question then reads, determine by means of a diagram. Determine by means of a diagram. Determine the first one, 2.1, tan squared A. Let me write 2.2 here. The second one, sin A divided by cos A. Thank you. That is what we the problem that we need to simplify. It's example 2. 5, the cosine of A plus 3 is equals to 0. And A is greater than 180 but less than 360. Determined by means of a diagram. Tan squared A, 2.2, sin A over cos A. Let's solve the problem. More often, the examiner at the end of the year can say determine by means of a diagram, or they can say determine without using a calculator. Without using a calculator means you don't have to calculate the value of A. That is what it means if they say without using a calculator. So we need to draw a diagram there. 5 cos A plus 3 squares to 0. Let me write it down. 5 cos A plus 3 is equals to 0. Make cos A the subject of the formula. You've got 5 cos A, which will be equals to -3 if you transpose 3 to the right. Now, let's divide by 5 both sides. If you divide by 5 both sides, you've got the cosine of A, which will be equals to -3 over 5. What does that tell us? In which terminal arm does angle A lie? Cosine is negative. Cos is negative. You've got a negative trig ratio there, negative. So in which quadrant is cos negative? If you look at the cast diagram, in the first and fourth, cos is positive. Second and third, there is no cos. Therefore, cos is negative in the second and third quadrant. Here we say our quadrant is second and third. We must draw a right-angled triangle either in the second or third quadrant. We must draw our right-angled triangle either in the second or third quadrant. Now we ask, which quadrant should we use? Let's read this statement further. Let's read. And here they say, and angle A must be greater than 180, but less than 360. Remember, you've got 0 here, 90, 180 should be here. So if they say it's greater than 180, but less than 60, they are referring to an angle. It's either in the third or fourth quadrant. It's either in the third from 180 to 360. Third and fourth quadrant are affected. So you've got 3 and 4, you've got 2 and 3. You look for a common quadrant. From the 2, 3 and 4, 2 and 3, the common quadrant will be the 3. So we draw a right-angled triangle in the third quadrant. It looks like this. It's X, it's Y, a right-angled triangle in the third quadrant. The terminal arm of that angle will then be in the third quadrant. And the angle we are talking about here is angle A. Thank you. Here is our angle A. And remember, the cos of A is -3/5. Cos by definition is adjacent over hypotenuse. So the adjacent here should be -3, the hypotenuse is 5. Great learners, take note that every time hypotenuse will always be negative. But as for x and y, they will keep changing depending on the quadrants. So in this case, y is negative from the x-axis downwards, y is negative, but the hypotenuse always positive. So that's why we allocate the negative here to 3 and the hypotenuse becomes 5. Now, if you look at it, we have 3 sides. We've got -3, which is the y, 5, which is the r. We still need to calculate the value of x. Let's calculate this side, which we call x, by using Pythagoras Theorem. And according to Pythagoras Theorem, the square on the hypotenuse is equals to the sum of squares of the other 2 sides. R squared is equals to x squared plus y squared. Our r, which represents the hypotenuse, is 5. Our x, this is what we want to calculate. Y is -3. If you square this one, it got 25 here. This one is x squared plus 9, because -3 what is squared is 9. If you transpose, you've got x squared. 25, that 9 you transpose becomes negative. 25 minus 9 will give you 60. Now we want the square root. Therefore, x will be equals to -4. Remember, the answer here, it should be plus or minus 4. X is plus or minus 4. And here I have chosen negative. The question is, why are we choosing -4? Look at the diagram. Remember, this is the origin. 0 is origin. From the origin to the left, x becomes negative. That's why we have -4. But if the diagram was either in the first or fourth quadrant, from the origin here to the right, x will become positive. We would have chosen positive if the triangle was drawn either in the first or the fourth. So that's why we say x is -4. So we've got -4 here. Now we can start answering the questions then. The first one was tan squared A. Tan squared A, let's check. Tangent by definition, it's opposite over adjacent. Go to your diagram. Here is A, opposite over adjacent. It will be -3 over -4. Because it's squared, you square that ratio. And when you square that ratio, the answer will be, if you square here, it will be 9 over 16. So that will be our answer, 9 over 16 to 2.1. Tan squared will be 9 over 60. Let's check the second one. The second one was sine divided by cos. It was the sine of A divided by the cosine of A. Let's check. What is the sine of A? You go to diagram. Reference to angle A. Sine is opposite over hypotenuse. This side is opposite. This one is hypotenuse with respect to A. So sine is negative 3 over 5. Divide. Allow me to, this is the same as the division. Divided by the cosine of A. Look at the cosine of A. Cos is adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent is negative 4 over 5. What answer do we get? Remember the laws of fractions. When you divide fractions, you need to change division to multiplication. So you've got negative 3 over 5. Now you multiply. This one will be 5 over negative 4. Let's see what the answer will be. The answer, negative and negative will yield positive, so we are left with 3 over 4 as the answer. Our final answer will be 3 over 4. This 5 will cancel that. 5 into 5 once, 5 into 5 once. So 3 by 1 is 3, 5 by 1 is 4, 1 by 4 will be 4 because negative and negative yielded positive. So here we've got the ratio when it's simplified is 3 over 4. These are the identities involving Pythagoras theorem. This is the second example. The first example that I did, already you were given the diagram. So if you are given a diagram already, the quadrant in which the point lie, it becomes easy because already we have a quadrant. So we worked it out like we did this one. Only this statement was given. So we had to simplify the statement, analyze the statement, draw from scratch, identify the quadrant and everything. So this one is a bit more challenging than the previous one. But as long as you know the cast diagram, I don't think you'll go wrong. In all these activities that we did, cast diagram is key because it helps us to identify the quadrant in which to draw a right-angled triangle. Remember, once you have a right-angled triangle, you need to know the three sides. All these activities, two sides were known. So to calculate the remaining side, we used Pythagoras Theorem. That's why even in this case, after writing down the cos of A is minus 3 over 5, having this triangle, we used the right-angled triangle to work out this side. So ultimately, x was negative 4. Let me remind you again. This is the origin. From the y-axis, you go to the left, x will be negative. If you go from the y-axis to the right, x will become positive. That's why here we end up choosing x as negative 4, because when you determine the square root both sides, it's plus or minus 4. But because of the diagram, we chose x as negative 4. And once negative 4 was written there, it was easy. It was just a matter of knowing the definition of the trig ratios. And then once you know the definition of trig ratios, you start substituting those ratios, and then you solve and simplify. You have the answers. Let me take you through one more example, the very last one. Example 3. If 4 tan b minus 4, Thank you. If 4 tan b minus 3, pardon me, if, let's start afresh, if for the tangent of b minus 3 is equal to 0, and the cos of b is less than 0, so our reference angle here is b. We talk about angle b, that is the reference angle. Determined by means of a diagram, 2.1, sine beta plus cos beta all squared. 2.2, 25, the sine of beta minus the cosine of beta. Let's go. Where do we start? Now we start with our solution. Or the tangent of beta is equal to negative 3. Which quadrant exactly I'm going to work with? Less than 0 means negative. Any number less than 0 is negative. So it means the cosine of beta is less than 0. Cosine of beta is negative. In which quadrant is cos negative? You must be knowing your cast diagram by heart. So the quadrant in the first and fourth, cos is positive. So the quadrant referred to here is the second quadrant and the third quadrant, because in the second quadrant, cos is negative. In the third quadrant, cos is negative. First and fourth, cos is positive. But this one, 4 tan beta minus 3 is equal to 0. Which quadrant are we referring to? For us to be able to identify the quadrant, let's write this expression in the standard form. 4 tan A, for the tangent of beta minus 3 is equal to 0. The tangent for the tangent transpose negative 3 to the right. It becomes positive. The tangent of B. You divide by 4 both sides. If you divide by 4 here, you've got the tangent of B, which is equal to 3 over 4. Here is the positive trig ratio. 3 over 4 is a positive ratio. So in which quadrant is tangent positive? No cast diagram by heart. Tangent is positive in the first and third. In the first and third quadrants. So from this 1 and 3, you go 2 and 3, look for a common quadrant. In that common quadrant, you will draw a right-angled triangle. So the common quadrant is 3. So we draw a right-angled triangle in the third quadrant. Let me draw it. X, Y, in the third quadrant. That is a right-angled triangle. Let me draw it nicely. So it should be a bit higher. Here is a right-angled triangle in the third quadrant. And according to tangent, tangent is defined as opposite over adjacent. Look at this one. Positive, positive. Tangent is 3 over 4, opposite over adjacent. So the opposite side here, if you look here, opposite side should be negative 3, because from the x-axis downwards, y should be negative. So you write negative 3 here. Adjacent is giving us 4. The ratio as a whole is positive, but if you look at this activity properly, in particular, the opposite over adjacent, the adjacent side should be negative 4. So, meaning when the ratio is given, this is simplified, basically minus 3 over negative 4. So negative 3 and negative 4 is positive. It's a simplified ratio here. But basically, this is the third quadrant. Y is negative, X is negative. Use Pythagoras to work out R, this remaining side. According to Pythagoras Theorem, R squared is equal to X squared plus Y squared. So we are given X as negative 4. You square it to Y as negative 3, you square it. This is the value of R squared. You say negative 4, when you square it, it gives you 16. Negative 9, when you square it, it gives you 9. So R squared is equal to 25. Determine the square root both sides. We want to eliminate the square. If you introduce a square root both sides, you've got R here as 5. R represent the hypotenuse, and the hypotenuse is always positive. X can be negative, Y can be negative, X can be negative, but hypotenuse is always positive, which is R. R here is positive 5. Now we can answer the question. What was the first question? 2.1. The sine of B plus the cosine of B. This is 2.1. Thank you. The sine of B plus the cosine of B, you square them all squared. All squared. Here it is. The sine of B plus the cos of B, all squared. Let's check the sine of B. Look at the diagram. Standard position, must be angle B. So, sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Plus, check the cosine of B. The cosine of B. Cos is adjacent over adjacent is -4, hypotenuse is 5. -4 over 5, you square it. Remember, positive and negative multiply, you always have negative. So here we may as well write negative. Now let's add the 2. If you add the 2, what is the LCD? The LCD is 5. 5. Then if the LCD is 5, you just add the numerators. -3 and -4, they will give you -7. Because it's all squared, you square it. Now, if you square it, you can write down the answer. In -7, you square it, it will give you 49 over 25. If you simplify this whole thing, ultimately the answer is 49 over 25. Let's check 2.2, the next one. 2.2, that's where we had 25 sine B minus cos B. 25, the sine of B minus the cosine of B. Thank you. This is equals to, you write 25 here, bracket. What is the sine of B? Here is angle B. Sine is opposite over hypotenuse, -3 over 5. Minus, check the cosine of B. What is the cosine of B? Cos is adjacent over hypotenuse, to be -4 over 5. -4 over 5. And remember, every time the two negatives coming after each other, negative and negative, they will yield positive. Negative and negative will yield positive. So we end up writing plus. Where does this plus come from? You have negative here. What is the cos of beta? -4 over 5. So the two negatives, negative and negative, will give you positive. Let's simplify. It's 25. What is your LCD? Our LCD here is 5. Thank you. 5 into 5 once. 1 multiplied by -3 is going to be -3. 5 into 5 once. 1 multiplied by +4 is +4. So basically, you just add the numerators, -3 plus 4, which will give you 5. Now let's simplify. If you multiply by this, 25 multiplied by 1 is 25, divided by 5, 25 divided by 5 will give you 5. So this one, when you simplify it, the answer is just 5. These are identities involving Pythagoras theorem. And like I said at the beginning of the lesson, the critical concept to know is cast diagram. Know cast diagram by heart, because cast diagram will enable you to identify the quadrant in which the trig ratio is negative. These questions, every time when they are asked, in this case, we had sine B and cos B. It can be any of the trig ratios. As you practice, there are lots and lots of activities that I will leave you with. In all those activities, you come across any 6 trig ratios: sine, cos, tangent, secant, cosecant, or cotangent. And of utmost importance, again, with regard to these activities, is for you to know the definition of the trig ratios. Imagine if you did not know the definition of psi. You have a right-angled triangle nicely drawn. What is the definition of sine? You need to know that sine is the opposite side over hypotenuse. We define the trig ratios using the sides of a right-angled triangle. So these definitions are only applicable in a right-angled triangle, because a right-angled triangle is the only triangle that has got a 90-degree angle. So we need to know the definitions. Once you know the definitions properly, everything else becomes easy. Definition of the trig ratios: know the cast diagram. Cast diagram, we have here 4 tan b minus 3 is equals to 0. Where did it lead us? Tan b being 3 over 4. Once you have this ratio as positive, in which quadrants? It's either the first or the third, according to the cast diagram, where the trig ratios where the right angle triangle must be drawn. So it's either the first and third. But if you read this one, first to second and third, cos beta is less than 0, second and third. Now you look for a common quadrant. In that common quadrant, you draw a right-angled triangle. You'll have two sides. The remaining side, use Pythagoras Theorem to work out the length of the remaining side. Once all the sides are known, know your definition. Sine opposite over adjacent. And it's important again to say, if a triangle is drawn like this, which side represents the opposite? Which side represents the adjacent? Which side represents the hypotenuse? So to make it easy, the horizontal, adjacent; vertical, the opposite; the sliding one, the hypotenuse. And hypotenuse is always positive. Check where your right-angled triangle is. Check where the sides are. In this case, from the origin to the left, x must be negative. From origin downwards, y must be negative. Hence, you have -4 and -3. Even though we're given tan beta as 3 over 4, practically, for us to solve the question, to answer the question, we had to use -3 and -4. -3 and -4 as indicated in the diagram, because the quadrant used here is the third quadrant. From there, apply definition, substitute. Apply definition, substitute. We did 2.1, we did 2.2, and then you can simplify further, get your answers. We have come to the end of the lesson. Hope and believe that this lesson will benefit you a lot. Keep on practicing mathematics, because you know our slogan in mathematics. The slogan is practice makes perfect. The more you practice, the better you become in mathematics. Thank you very much, and I wish you the best.